waking up tomorrow. You turn on the shower. The water pressure is suddenly weak. The kitchen faucet barely flows. Across town, firefighters are fighting a major fire while the city's water system is under heavy demand. And then something strange happens. The pumps at the treatment plant aren't doing all the work. So, what is actually pushing all that water through the city? The answer may be standing hundreds of feet above your head. Every day, Americans drive past giant tanks rising above their towns without giving them a second thought. Some look like giant metal balls. Others look like mushrooms. Some are covered with a town's name or local mascot. They seem almost outdated, but behind that strange shape is a remarkably simple piece of engineering. Because a water tower isn't just a place to store water. It's a way of storing pressure. And once you understand that, the entire system starts to make sense. Drive through almost any part of the United States with a public water system, and eventually you'll probably see one. A huge tank elevated above the surrounding buildings. The obvious explanation is simple. It stores water, and that's true. But there's a problem with that explanation. If the goal were simply to store water, why put the tank so high? Why spend money building an enormous structure just to lift millions of pounds of water into the air? Because the height is the entire point. USGS explains that one common arrangement is for a water utility to pump water into an elevated tank, then allow gravity to move that water through the distribution system. The tower isn't simply storing water, it's storing energy in the form of elevation, and that energy becomes pressure. Think about a bottle of water. Hold it above the ground. Now imagine putting a small hole near the bottom. Water immediately wants to move downward. You don't need a motor. You don't need software. You don't need electricity. Gravity does it automatically. A water tower uses exactly the same basic principle, just on a massive scale. Water is pumped upward into the tank. Then, when water is needed throughout the community, gravity helps drive that water downward through the distribution network. The higher the water surface is relative to the people using it, the more pressure the system can generate. That's why the height of the tank matters so much. A water tower is essentially turning height into pressure, and gravity has one enormous advantage. It doesn't need to be switched on. But now there's a problem. If gravity can move the water, why do cities need pumps at all? Because the tower doesn't create water. It doesn't fill itself. Pumps move water from a source or treatment facility into storage. And then the elevated storage helps the distribution system deal with changing demand. Imagine a normal weekday morning, 6 o'clock. Most of the neighborhood is asleep. Water demand is relatively low. Then 7 o'clock arrives. Showers turn on. Toilets flush. People brush their teeth. Coffee machines start filling. Dishwashers begin running. Thousands of people can suddenly start using water at roughly the same time. Demand changes throughout the day. And that's where storage becomes extremely useful. Instead of forcing pumps to respond to every tiny change in demand, the elevated tank acts as a buffer. During periods of lower demand, the system can replenish storage. During periods of higher demand, water can flow out of the tank into the distribution system. Historic engineering records describe elevated storage as a way to regulate peak periods and provide reserve capacity when pumps cannot instantly match changing demand. So the tower is doing something surprisingly sophisticated. Without using sophisticated technology, it's smoothing out the city's water demand. And this is where the design becomes really interesting. Imagine the power goes out. A storm damages electrical infrastructure. The pumps stop operating normally. Does that automatically mean every faucet in town stops flowing? Not necessarily. An elevated tank can continue supplying water through gravity while the system works to restore pumping capacity. The tower has stored water above the distribution network, so even if the electrical system temporarily struggles, gravity is still there. This doesn't mean a water tower can keep a city running indefinitely during a blackout. It can't. The available storage and system design determine how long it can support demand, but it can provide something incredibly valuable. Time. Time for backup systems to start. Time for operators to respond. Time for power to return. EPA describes storage facilities as an important part of drinking water distribution systems, which also have to support fire protection and maintain adequate pressure under changing conditions. In other words, the tower isn't just about convenience. It's part of the system's resilience. Now imagine something much more dramatic. A large building catches fire. Fire crews arrive. Multiple hoses begin drawing enormous amounts of water from the distribution system. That's a completely different situation from someone taking a shower. For a water utility, fire protection can create very high flow requirements. That's why water distribution systems are designed with fire protection in mind. The American Water Works Association notes that utilities commonly design additional capacity so that large flows and adequate pressures are available for firefighting. Elevated storage can be part of that overall system. It provides water that is already positioned above the distribution network. And that matters because the system doesn't have to create every extra gallon of flow at the exact second demand suddenly rises. The tower can act as a reserve. Again, the genius isn't that the tower is complicated, it's that the tower is simple. So how did giant water tanks become such a familiar part of the American landscape? Part of the answer is geography and the way American communities developed. Many towns didn't have a convenient natural hill where engineers could simply place a reservoir high above the distribution system. So engineers created their own elevation. They built the storage tank and then built the structure underneath it. The concept became an important part of municipal water systems during the late 19th and early 20th centuries. The Library of Congress documents numerous historic examples of elevated storage being used for municipal water supply and fire protection during this period. And as communities expanded, the water tower became more than just infrastructure. It became a landmark. A town might paint its name across the tank, add a school mascot, a company logo, or a giant piece of artwork. Suddenly, a piece of civil infrastructure became part of the community's identity. Look at water towers across America, and you'll notice something strange. They don't all look alike. Some have narrow legs supporting a large tank. Some have a massive central column. Some resemble giant spheres. Others look like enormous cylinders. That's not just decoration. Different designs evolved to solve different structural and operational problems. As steel construction technology improved, engineers developed new shapes and support systems that could hold large quantities of water efficiently. The Library of Congress documents this evolution from earlier standpipes and water towers to the elevated steel tanks that became common in the 20th century. And there is one detail that makes the engineering even more impressive. Water is heavy. 1 gallon weighs about 8.34 pounds. So a tank containing 1 million gallons would hold more than 8 million pounds of water. That's thousands of tons. Suspended above the ground, the entire structure has to carry that load safely while also dealing with wind, weather, corrosion, and the forces created by the movement of water. This isn't just a tank on stilts, it's a carefully engineered structure. And keeping one operating isn't simple either. Water storage facilities have to be inspected and maintained. Steel needs protection from corrosion. Tanks have to be kept sanitary. Sediment and other problems can develop if storage facilities aren't properly managed. EPA specifically identifies finished water storage facilities as an important area of water system operation and notes risks involving physical access, contamination, sediment, and biofilm. So that giant structure you see from the highway isn't simply sitting there for decades untouched. Someone has to maintain it, inspect it, protect it, and make sure the water inside remains safe. Now we reach the obvious question. If modern pumps are so powerful, and computers can monitor water pressure in real time, why do we still need giant tanks in the sky? The answer is, sometimes we don't. Modern water systems can use different combinations of pumps, ground-level storage, reservoirs, pressure control equipment, and elevated storage. The right solution depends on the community. But that doesn't make the water tower obsolete. For many systems, elevated storage remains useful because it combines several functions in one relatively simple structure: storage, pressure support, peak demand buffering, and emergency reserve. And the most remarkable part is that one of its most important functions still relies on something discovered long before modern computers existed: gravity. So the next time you're driving through an American town and you see one of those enormous structures rising above the rooftops, look at it differently. It's not just a tank. It's not just a landmark. And it's certainly not useless infrastructure from another century. It's a giant piece of stored potential, using nothing more complicated than water, height, and gravity. When demand rises, it helps. When pumps struggle, it can help. When the electrical system fails, it can buy valuable time. And when millions of people turn on their faucets every day without thinking about where the water comes from, that giant tank quietly does its job. No screens, no apps, no complicated interface. Just physics. Sometimes the smartest engineering isn't the newest technology, it's the simplest idea. That still works. And that's exactly why these giant structures are still standing above America today. This is modern mechanism, where we uncover the overlooked systems, machines, and infrastructure that keep everyday America running.